Okay, I made up a new piecewise function so you can watch, but then do the one in the test review yourself. Okay, but it's very similar in structure. Drawing piecewise functions is a little bit of an art. Um, uh, my recommendation is that you um, focus on drawing the functions first. Okay, draw these functions first, and then um, kind of erase the parts of the functions that don't fit within these domain restrictions, okay? And then last, we're going to look at kind of what you would call the endpoints, the critical points. We'll look at this, and pay attention to whether the inequality has an equal sign, okay? That way, we'll know if we're drawing it in a closed circle or an open circle in our graphs. Okay, let's start with this, negative 1/2 x. So we got to remember, rise over run. Negative slope means I'm going down. The person on the slope is literally walking down. And you also have to remember y equals mx plus b. This is the y-intercept, but there is no plus b. So the y-intercept you got to assume is 0. We'll go through the origin. So let's start to draw this a little bit. Negative rise and a run of 2. So if I start here, that's a good one. That's a good one. That's a good one. And here's the thing. So this, oops, I totally messed up. The rise is 1, the run is 2. So the rise is 1, the negative rise is like this. Got my slope wrong. So these are all going to be part of negative 1/2. But here, the domain, the only eligible part of this function for this graph is whatever is between negative 6 and negative 2. So 1, 2, 3, 4, 5, 6. Oh, right there. So I'm allowed to have this. And because it says less than or equal to, or greater than or equal to, the x is in between, I'm going to keep that as a closed circle. And I'm allowed to go up to negative 2, which is right here. And because that inequality says open circle, I'm going to, is less than, but not equal to, I'm going to make that an open circle. So the domain restriction tells me get rid of everything else, but what's in between? Okay, so this is the first piece. Okay. The second piece is y equals 1. I mean, that's a horizontal line at y equaling 1. So we're talking about a horizontal line like this. And the domain restriction here is they only want us to show x between negative 2 and positive 3. So negative 2 was back here. 1, 2, up to here. So we've got to stop there. And the stop, it looks like there's an equal bar under that inequality, so it includes the x equals meaning 3 right there. Okay, so that's good. And then, okay, now we've got a quadratic. Remember, this part on the inside of the function means go to the right 4, and outside of the quadratic function is up or down. We're going down by 3 from the origin, which is the parent, where the parent function would be. So right by 4. 1, 2, 3, 4. Down by 3. 1, 2, 3. So this is the vertex. And this is not flipped over because I don't see a negative out here. I don't see a negative. So it's going to point up. When you draw a parabola, after the vertex, the next point up on either side is just catty corner. Okay? And then the next point on either side is that it's over 2 up 4 because 2 squared equals 4. Right? So over 2, 1, 2, 3, 4. Whoops. But if we do it over on this side, we're going to bump into here. And I don't think we have overlapping domains. We shouldn't. So where the horizontal line stops at 3, we pick up at positive 3. And it's open circle because it's just greater than. So here's 1, 2, 3, positive 3. So that's got to be an open circle. Right there. Let's make that a little clearer as an open circle. Open circle. And how far out are we supposed to draw this parabola? 6. So 1, 2, 3, 4, 5, 6. We got to stop right there, actually. We stop right there. Oh, and I'm noticing that inequality does not have an equal bar. So that's also right up to the 6, but not being 6 is what we're looking for. Okay, so here's our parabola. I'm doing the final piece of the piecewise function. And there we go. Now, another thing that you can do to kind of verify that you're in the right place, if this gets confusing, is take the ends of these ranges, like this -6, as an x, plug it in here, see what y you get. See what y ends up being. If y is -1/2 times -6, we're talking half of 6 is 3, negative is positive 3. And so you're going to be saying, hey, there should be a point -6, 3. And if x is allowed to be -6, then there should be a closed circle there. So guess what that point is? That's right there. If you want to make sure that your line stops in the right place, this is the other end of the domain restriction. Same thing. Take that and put it in here. Y equals -1/2 times -2, which is positive 1. So that point should exist. And because there's no equal bar under there, there's no equal bar, you're going to have an open circle there. It's probably most useful for the parabola because maybe squaring a binomial like this gets confusing. But let's just make sure we've stopped drawing in the right place. Let's take the 6 and plug that 6 into x. So what we're getting is 6 minus 4 squared minus 3. 6 minus 4 is 2 squared minus 3. 2 squared minus is 4 minus 3, which is 1. So if the x that we used was 6, the y turns out to be 1. And that point is indeed this point right there.